So with that, we're going to introduce Anthony Shelton, professor of entomology at Cornell, and also a UCR alum, and he will be talking about the intersection of biotech and food.
Okay, so first of all, I'd like to thank Norm for inviting me. This has been a wonderful, wonderful conference. I wish there were about 2,000 people here, because it helps develop the future. And it's very stimulating, and I really, really appreciate it. I also have a hell of a cold. Because we got about 2 feet of snow in upstate New York. And I was out shoveling snow a couple days ago. So what I'm going to be talking about, well, let's see. Let's see what I'm going to be talking about. Okay, I'd like to pose a question to you. How do you think we should control agricultural insect pests? Before you give me an answer, these are some of the problems caused by agricultural insect pests. So we have, we have a problem with the slide projector. Which is the laser? Button in the middle is the laser? Okay, so we got corn here, consumed by a number of Lepidoptera and species. Codling moth, this is a potato plant, colonized by cholera potato beetle. That's cauliflower in India, destroyed by diamondback moth. So, and we have spotted wing Drosophila, a new invasive pest. We have citrus greening. How do we control these insects? How do we? A lot of it is by insecticides. We have a number of different insecticide classes. We treat it by airplane, by ground rig, by seed treatment, by drip irrigation. Is this a sustainable method of controlling insect pests? Whoops. Back in 1959, Vern Stern, who was a faculty member at Riverside, emphasized this concept of integrated pest management, or IPM. Some people call it IPM, I promise more, or integrated pest management. But it basically tries to put control into this concept here, which is to avoid pests, sample the crop, and then treat when needed. But the big thing right here is to try and avoid the pest. And we have a number of different ways, different tactics that we can do this. We can manage the landscape, plow the crop down at the end of the season so the pests don't spread. We have biological control, which we can encourage. Cultural controls, anyone know what that means? It's not like taking the insects to the opera or anything like that. But it's using things like plowing down the crop, or planting at certain times, or some way of avoiding the insect. The most important part, though, here is host plant resistance, right in the middle. That is the key one. And that's what we try and do as entomologists. How do we develop host plant resistance? Fortunately, we have this amazing thing going on called evolution, where we have a diversity of plant species, from gymnosperms to angiosperms, and many of these, over time, because of this great ball of radiation that we have in the sky, which we don't oftentimes see in Ithaca, New York, gives a lot of genetic diversity. Some of that genetic diversity has caused resistance to particular pest species, insects, or diseases. And we can utilize the genes in this large crop family and put those into our commercial crops and get resistance. However, sometimes we may not be able to have that. We may not be able to discover that. So this is actually a picture from a general plant breeding book. Sometimes if you don't have resistant genes out in the wild, you can actually create that resistance by imitating the sun. And this is an Institute for Radiation Breeding in Japan. And this is a circle here with a number of fruit trees shown here. And in the middle, there is this source of cobalt-60 that pops out of the ground, gives a wallop to all these trees, causing changes in the genome of those trees. Commonly done, and sometimes this sledgehammer method will actually result in some good changes in the chromosomes of those plants. In this case, there was an Asian pear that was improved. This Asian pear, which is susceptible to a black spot disease, but after radiation breeding, you got Asian pear that is resistant to it. You can still find this on the market. I know you've all finished your lunch. I hope you don't get sick on this, but this happens all the time, and it's a natural phenomenon. In fact, if you look at a number, there's about 3,000 crops, 3,000 varieties of crops that have been bred through radiation breeding, including wheat or barley, cacao, pink grapefruit, is developed through radiation breeding, sunflowers, bananas, all enhanced through radiation breeding. It's a hell of a shotgun method. Not really the greatest way to develop host plant resistance. But they're out there. As an entomologist, I'm looking for genes that cause resistance to certain insects. C. Michael Smith wrote a book in 1989 called Plant Resistance to Insects. And he said there's about 100 crop-resistant cultivars that are grown in the US that have some resistance. Most of this successful host plant resistance has been to what we call sucking insects, although maybe in the audience think that all insects suck. But there's been little success for host plant resistance for Lepidoptera. Those are caterpillars. And Coleoptera, those are beetles. Those are two major insect orders of pests. We don't really have good resistance to it. But then along came an understanding of Bacillus Thuringiensis, or BT. It's a common soil bacterium which produces a protein that's toxic to some insect species. There's many, many different strains of BT. It's been sprayed on crops for 70, 80 years. Very, very safe to humans and the environment. However, it accounts for less than 1% of all insecticides. That is when it's sprayed on. It's a very, very safe material. I brought this through from our lab. It's just BT. It's just a commercialized BT formulation. Got it through TSA. They got some other things to worry about right now. But, whoops, what happened to that one? But it's really safe. I can taste it. Although I got cold now, and I don't really taste anything very well, but you know, it's just not bad. You know, I don't. Anyway, it's incredibly safe, and some people in universities and in industry had the idea, why not just take the genes for the proteins that are insecticidal and put those into plants? And this is this paper that was in 1987 by Fishoff et al. From Monsanto, talking about creating insect-tolerant transgenic tomato plants by taking the genes from there and putting it into a plant. Just a wild-ass idea, except it really worked. That was for tomato plants. And I love this last little sentence in their abstract. These engineered tomato plants represent a significant step to increase selectivity, specificity, and efficacy in insect control. They sure do. They were first put on the market in 1996 in corn and cotton. And by 2017, we have 101 million hectares of BT crops grown globally in about 25 different countries. That has been just a marvelous, marvelous benefit, I would say, to agriculture. What has it done? Well, in maize, it's reduced the active ingredient insecticide by about 53%, and cotton by about 29% from 1996 to 2015. What other invention in agriculture has done this much? So we actually have transgenic BT plants providing this host plant resistance. I spent my career, however, not in corn and cotton, but in vegetables. So I'd ask myself these questions: why are if BT crops are so good, why are they not more widely used? Well, the crops of interest may not be available or suitable. Crops of interest are largely that are not available are BT vegetables. There could also be a lack of resources to create a biosafety law and rules that would allow their production in certain countries. This is really a problem in Africa. Cultural differences, don't want that stuff. I don't want genetic engineered stuff. Lack of political will, I'll talk about that in just a minute. Anti-biotech groups like Greenpeace. When I was in college, I thought Greenpeace was great. They were against above ground nuclear testing. They were for saving the whales. It sounded really good. They've gotten away from that. So, in vegetables, I look at it, the Green Revolution did a marvelous job of producing calories for people through rice, through wheat, and through maize. However, about 1 billion people are suffering from what we call the hidden hunger of malnutrition because they don't get the vitamins and some of the minerals that are really, really important. And this is what happens when malnutrition occurs. Vegetables and fruit are full of all sorts of minerals and vitamins that are really, really needed. Why can't we get some of this technology of genetic engineering and use that for vegetables? Another thing I'd like you to think about, this is the total insecticide use globally is about $16 billion. Put that into perspective. I guess if you really wanted to build a wall, you could build 3 walls with that. Fruits and vegetables constitutes about 45% of that. Okay, so we're encouraging people to eat fruits and vegetables, but they're also sprayed very, very heavily because they've got they have high cosmetic standards, and they have a complex of insects that attack them. So, since about 2002, I've been working on a project with USAID and with Maiko, which is an Indian seed company, about trying to introduce eggplant, BT eggplant, into Asia. Eggplant is attacked by something called the eggplant fruit and shoot borer. It's a caterpillar pest. This is the damage that it does. This is how farmers try and control it, with up to 100 sprays during about a 3 to 4 month period, sometimes spraying 2 or 3 times a week, sometimes actually dipping the eggplant into an insecticide before it goes to market. Notice the personal protective equipment that this guy has? Absolutely nothing. This is the way the world works in developing countries. Here is Usha Barwali, who is the vice president for MICO, giving some transgenic BT seeds to this fellow here, who's a chancellor at Tamil Nadu University in India. And then they put it into their local varieties. This is what the eggplant looks like, the BT eggplant. No holes in it at all, much higher yield. This is what it looks like when it's not BT. And you can even see a lot of holes in there. It's a black and white situation. We worked with India for 10 years to try and get this to market. Greenpeace decided that they did not want this to go to market. And they spent about a $100 million campaign to derail it. This is a picture of a protester presenting what she called the last non-genetically engineered plants to this minister here to make him aware of what she thought was going to be genetic pollution by introducing genetically engineered plants into India. Greenpeace has an anti-biotech policy. After 10 years of development and passing all the safety courses and everything, on February 9, 2010, the Ministry of the Environment and Forest placed a moratorium on its use, and there it sits today. So what farmers are having to do is just go back and spray the hell out of eggplant. Not long after this, the Minister of the Agriculture came to Cornell, and she said, we would like eggplant or brinjal is a very important crop in our country. We would like to go ahead with BT eggplant. And I said, well, you know what happened in India? And she said, we are not India. We're a very poor country in Bangladesh. My job is to feed 160 million people and to protect the environment. And if BT eggplant will help us do that, let's move forward with it. BT brinjal in Bangladesh, it's the second most popular vegetable. It's produced by about 150,000 resource-poor farmers. Farmers spray insecticides 80 to 100 times. No personal protective equipment. From 2004 to 2012, MICO, the Indian Seed Company, developed this event EE1, this BT eggplant. They donated it to BARI. BARI put it into their local varieties, and they applied to release 9 BT varieties in 2013. In 2013, these 4 lines were approved for commercial production. This is the Minister of Agriculture in Bangladesh giving this farmer some transplants of BT eggplant to put in his field. We had 20 farmers in 2014. In 2018, we have 27,000 farmers in Bangladesh adopting this technology. And it's even more than 27,000 because it's an open pollinated line so farmers can save their own seed. This is really making a difference in the country. BT brinjal or eggplant, in the BT it was less than 1% infestation compared to the non-BT. Even when sprayed, non-BT had 48 to 57% loss. Insecticide reduce was by 61 to 98%. I talked to one farmer and I said, how many times did you spray? Because they still have to spray for thrips and aphids and other insects. He said, I sprayed my field twice. I said, how many times did you spray last year? And he said, over 100. 98% reduction. He had a 6-fold increase in the net returns, which is substantial. We've conducted studies that have shown no harmful effects of the BT brinjal on non-target organisms. Thousands of Bangladeshi farmers have been trained. The Bangladesh Agricultural Research Institute is producing the seed and distributing it. And we have worked with them on capacity building. They have adopted much more rigorous stewardship practices. So it's getting out there and it's helping farmers. We're under the microscope because this is the first food crop in a developing country that is actually out there making a difference in people's lives. So you can go on to bteggplant.cornell.edu. We have a website where we put much of this information. We also we work with the Alliance for Science, which is a Gates-funded project to help farmers have a voice in developing countries about the need for genetic engineering. We have YouTube videos. We have field days. In fact, I was just in Bangladesh in the first week in January. And it's just like a field day, a farmer's field day in upstate New York. We talk with farmers, or I have to have a translator talk because I don't speak Bengali. But, you know, we asked the farmers after we had this farmer tell the farmers about his experiences, and we said, how many people are interested in continuing or to grow BT eggplant next year? Every farmer raises his hand. This is really, really helping. We also have Twitter, it's on Facebook. This is making a difference in people's lives. This is the Minister of Agriculture who at a meeting in March said, you know, her attitude on it is, because she does get pushback from other ministers and from, you know, NGOs, her attitude is saying, we will be guided by the science-based information, not by the non-scientific whispering of a section of people. Man. Can you imagine anyone in the US government saying something as strong as this? Even on a tweet. It's making a difference in people's lives. You know, look into the eyes of this farmer here. See how happy he is producing this. When farmers are spraying, you know, this 100 times during the season, the farmers, you know, in surveys that we've conducted or other people have conducted, farmers say, you know, they're throwing up afterwards. They have skin irritation. They don't have any personal protective equipment. Most of them are spraying in bare feet. They have no, you know, they're very, very susceptible to the insecticides that many of them are no longer used in the US. So this farmer, you can see why he's so happy about it. His wife and his child are walking through the fields now. I love the expression on this little girl's face. So it's making a difference in people's lives. And it's really the only genetically engineered food crop that is out there in a developing country right now. The technology was developed for corn and cotton. Why can't we use it more in vegetables and fruit? These important group of crops that really will help fight malnutrition. Thank you.